to move this one over here. Let's put that back there. And there we go. Okay, so here we have area of a triangle is equal to 1/2 base times height. So in this case, we're going to take this equation right here, what we got, and we're going to plug that in to our base, because our base is actually going to be doubled because it's 2 r's. So we will have area is equal to 1/2 2 square root of 2rh minus h squared times r minus h, which is right here. This is actually our height that we have, so that's our r minus h. And then this is the equation for the area of the triangle. So this equation that I just wrote out is actually going to solve for that area there. That's what we will solve for there. And then what we want to do is we want to solve this angle here. So we have this angle, we're going to call that angle theta. We want to find what theta is. So we're going to write this as cosine. Cosine of theta is equal to r minus h over r, which, according to SOHCAHTOA, it's adjacent over hypotenuse. So in this case, we got our adjacent over our hypotenuse. So it's r minus h over r. That's how we got that. So the next step is we're going to solve for theta. So we'll solve for theta. And what that ends up looking as is arc cosine of r minus h all over r is equal to theta. So next we're going to solve for the area above the triangle. That's what we're solving for now. So in this case, since there's 2 parts, we're going to have 2 arc cosine of r minus h over r minus our square root of 2rh minus h squared, and then r minus h. So now we know the area of the top. Hold on, let me just check something there. Actually, hold on. I wrote that wrong, excuse me. So it's actually 2 arc cosine of r minus h over r over 2 pi r squared pi r squared minus the area of the triangle found already, which is the square root of 2rh minus h squared, put that in parentheses, and then r minus h. And now what we'll do is we'll clean that up, and we will now find only the top area. So the area of the top is equal to r squared cosine, arc cosine of r minus h over r minus the square root of 2rh minus h squared r minus h. And the way we got to that is these 2's canceled out, this pi canceled out here, and this r squared canceled out here. And we actually had another r squared, which is why this stuck around. Yeah, this r squared was not there. So we kept that r squared, which was brought down to here. Now we know the top area. What we want to find is the bottom region of the circle. So we're going to plug the area of the top into the density of the water times the area is equal to the density times pi r squared. So we'll do the density of water times the area equals the density of the log times pi r squared. So we'll rewrite this as the density of water of pi r squared minus r squared arc cosine of r minus h over r minus the square root of 2rh minus h squared of r minus h is equal to the density of the log times pi r squared all over pi. Actually, so now what we want to do is find the density of the log, so we'll divide by pi r squared, and what we end up getting, I just want to make sure this don't frame, we'll get the density of the log is equal to the density of water of 1 minus 1 over pi arc cosine of r minus h over r minus 1 over pi r squared square root of r squared 2rh minus h squared over r squared, and then r minus h over r. So we will simplify that down, and we will end up getting the density of the log is equal to the density of water. And then that's 1 minus 1 over pi arc cosine of 1 minus h over r. That r, those both cancel, and then we'll get an h over r here. Minus 1 over pi, and then these r's they'll end up canceling, so this r will come out, this r will cancel, so we'll get 1 over pi, and then we'll get the square root of 2h over r minus h over r squared times 1 minus h over r. So that's what we get. And then I'm going to put our original equation back up just so we know what we're looking for. So we get Sg is equal to the density of the log over the density of water. And then what that looks like, since the density of the water cancels from the equation above, we end up getting this, so this water will go away. So we're going to plug this back in. So everything we have, we're going to plug into the log. So we'll plug all of this back in because this water cancels. So we're going to get standard gravity is equal to 1 minus 1 over pi arc cosine of 1 minus h over r minus 1 over pi square root of 2h over r minus h over r squared and 1 minus h over r. So that was part 1 of our solution steps. The next step will be actually coding it and showing how we got the solution through that.